least squares, but now for second order. I'm going to give you the notes, and then we're going to program it. Probably give you a little bit more notes today than last time, but it's good. Okay. So this is second order, right? AX squared plus BX plus C. Give me some examples where you see quadratic, so the quadratic equation. Anybody know? What about like energy? Where do you see an x squared term in energy?
Not potential, but
Potential. The spring, right? In dynamics, you're going to get this when you get to potential energy. Almost every question, if it has a spring, you've got to use quadratic equation. Okay. So quadratic. So springs, but also today we're going to look at density as a function of altitude is actually quadratic, pretty close. Okay. So if you remember from least squares, we're trying to minimize the air. So we take our experimental value, we subtract it to our linear equation value, where I just substituted that in, and we square. That's why it's called least squares fit. Okay. Yep. So remember, yi, this is your experimental data, and this is actually right here. This is your linear fit. So you're taking your experimental and you're subtracting what you think it is, and you're squaring that. Okay. We're trying to find the minimum. Okay. So when we try to find the minimum, we have to take the partial of s with respect to a, and we set it to 0. Equals. We're going to do 2 more. So what we need to find is we need to find these coefficients, right? A, B, and C. So if we take the partial derivatives and we set them to 0, that means we're finding the minimum. And we do it 2 other times, we'll have 3 equations, 3 unknowns. Right? If it was a third order, how many derivatives are we going to need? 4, because it'd be it'd be A, B, C, and D, right? Set them to 0 and then do it. Okay. I hope. Oh, go ahead. Because this is the, so if we have a data point, we have data that looks second order. Let me see here. Do I have it? I don't think I have it on me. You'll see here in a second, the data actually looks quadratic. It's second order, okay? So that's what we're trying to fit. We're trying to fit and find a theoretical equation that matches that. Okay, does that make sense, Israel? Now, question, your derivative, does this make sense? That first part, where did that come from? Nope. Because this whole thing is all squared. So this comes up front, and that's why it's all 2 times all of that, right? And then you subtract 1, and then what you have to do is you have to take the derivative of the inside, which is you take the derivative and then with respect to a, right? So it's just xi squared. Because a, you're taking the derivative of this function with respect to a. So whatever's there is a constant. You just keep that. Okay? Right here. Yep. The negative's right there. Yep. Yeah, you have to multiply by negative through. Yep. So this one should be what? Summation of 2 y minus ax I squared plus bxi plus c times what? Negative xi, right? So if you notice, 2 classes already in this. We're doing a lot of stuff at you, right? Statistics, regression, fit, partial derivatives. But that's fine. Get you through it. And the last one, which color do you want to do? Purple? Summation of 2 yi minus axi squared plus bxi plus c to the negative 1. And again, I do this just to help you understand some of the method, some of the math, which will then hopefully help coding, okay? Okay. Now, there's 3 equations, 3 unknowns. If you really wanted to, you can plug one into the other, plug that into the last one, and then rearrange, right? That is so much harder than what I'm going to show you right now. Okay. I'm going to make life easier, and I'm going to make 3 more lines. Okay. This is basically this line up here. Yeah.
Would it be even easier just to do like y or like a just time equals all that stuff that's the same for each and then do that later?
Say that again.
So call like maybe like z, so summation of 2 yi minus blah blah blah, because it's the same for all 3.
Well, you're trying to factor out a, b, and c though.
Oh, okay. Well,
That's what. Yep.
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 I got you.
Can everyone see where this green line came from? If you multiply negative xi squared times negative ax squared, what do you get? That, right? Next one, negative xi squared times bxi is that one, right? Do the same thing with c, and then I multiplied this times yi. Okay, where did the 2 go? Now, that was one option, but also it's equal to 0, right? So you can divide by 2 and it doesn't matter. Okay. Yep. What's that? Yeah, all these equations equal 0 because you're trying to minimize the error. Yep. It can go right away. Yep. 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 Even if it was another number, it could actually go right away too. Yep. Next line, I'll do in whatever color this is. Should be A, summation of xi cubed plus B, summation xi squared plus C, summation of xi equals summation of xi yi. So far, making sense? You see a trend? Should start seeing trends, right? If I did the next line, without even kind of looking at that, this should be xi what? Squared plus b summation of xi, right? Plus c, well, it's actually the summation, which turns out to be, this is from I equal to, this is really like a 1 to n. But if you're adding 1, 2, 3, 4, 5, 6, 7 all the way to n, if you add all that, this is just n times c. Okay? So anytime you see just a summation with a 1, that's the number of samples. Okay? And then this should be the summation of what? Yi. Because you still got to, in this c times n, you still got to put the summation term because you have that. If you're just summation and you're going from I equal 1 to n, that's just, you just add them up. So most of you have taken physics 2, right? Okay. Remember the Kirchhoff's equations or the currents? How many equations did you have? Like 7 or 8 or 9? Okay. What did Dr. Hong or Dr. Oneni make you do? Do it by hand and plug one into the other, right? Well, what I just did here was I factored out the unknowns, A, B, and C, with coefficients. And I'm going to do some linear algebra. I'm going to do reduced row echelon, which is a shortcut in MATLAB, that will find the answers. Okay? So we're going to make a matrix. We're going to call it A. Oh, I might need it bigger. So let's write the matrix, and then we'll write where the terms are. Sorry, I'm quiet. I should be talking, but it's all right. Then we got n, and we got the summation of yi. We're almost getting ready to program. And you can do this to any set of equations. Even if there's 2 equations, you can do this. Okay? Anything after 2, you should always now know, do this form. Write your coefficients in front, and then do the shortcut. Because what's in this column? This is A, right? This column, B, this column, C. If you notice, it equals the number. Okay. So that's how, when you're looking for unknowns in equations, each column represents your variables, and then it equals a number. I hope the students that took linear algebra that had a rough time because of this was the main thing that you got out of the class. Because that's. I remember that. Yep. I am not going to show you how to do it, but what I'm going to show you is this. In MATLAB, we can say RREF of that. And what we'll end up getting is this: 100A, 010B, 001C. Calculator in like a TI-83 or plus or whatever higher, you can do a program that does this. Yep. So when we reduce row echelon form, we can find our coefficients A, B, and C. What we just did here was linear algebra for students that haven't taken it. Okay. So, what's that? Yeah, in linear algebra, they're going to show you how to do it by multiplying each row by something and subtracting, but this is the shortcut. Okay. All right, you ready to program now? Switch gears. We got notes. Okay. Looks like everyone. All right, go ahead and open MATLAB. Yeah, go ahead. Oh, you don't need them. Nope, not today. Nope. Let me magnify. So I'm going to skip the header just to save some time, but for you, I would make and copy paste the header so you know and save it in a spot. So I'll give you a few seconds if you want to put that. All right, so we're going to plot, what did I plot here? Density versus altitude. That's going to be second order. Given Z 0, 1, 2, 3, 4, 5, 6, 8, 10, 15, 20, 25. This is kilometers. Some of you, for intermediate fluid, we did the terminal velocity, right? Remember that in the final exam? Terminal velocity versus altitude for trench ball. And I told you to change the density.
I did one to mix up here.
Yep. 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 So these are altitudes in kilometers. And then I'll give you the densities. Actually, before I stop teaching thermo, anybody have me for thermo? I don't think so. You didn't have me for thermo. No, for thermo.
I didn't even.
I don't think you did either, right? Yep. This is their homework 1, was to do this. I hear your fingers hit the keyboard. Ansys, yeah, probably Ansys, yeah. All right, we have to know the length of these, right? Or how big this matrix is. So I could pick Z or rho, but I just picked Z because it's shorter. Now we're going to build the A matrix. Thought I put that extra touch in there. We're not gonna do for loops. We're just gonna do sums. So A11, I think, is the summation of xi squared, right? Because we're gonna plot rho versus z. Does everyone see that? So z is our xi. Okay. You want to put that up here so you know. And this is our yi. Someone tell me what A12 is going to be? Nope. So where is A1 comma 2? So the first number is your row. The second number is your column. Should be the xi cubed, right? Am I blowing minds right now? And why don't you try A14? Summation of what? Yep. Bingo. All right. Well, we got a lot, right? We got A21, A22, A23, A24, right? So 2-1. Can I do this? Is that correct? Is A21 equal to A12? I think so, right? Yep. A22? That's funny. A13? A23? That one we have to put in something. And then this one we do 2, right? E times row. Okay, I'm going to do the last one. A31, A32, A33. Then I think we need A34. I think this one is the same as what? A22? A23 and summation of row. No comment. Okay. Try to build the A matrix. Can you? So I like to do spaces. So this would be A11, A12 to the next row. A13, A14, and then semicolon. And I like to put the 3 dots and then kind of line up my next one, right? Did I do that right? Oh yeah, A24. A31. Which one? Oh yeah, right here. Good call. So make sure, I forgot that, you need a dot before the multiplication for that on line 18 and my line 18 for A14. Those dots will get you every time. What? Oh, been on bump. 15 minutes. Now, B equals, oh, why is there a space? Yeah. B equals RREF of A. And then keep the semicolon off. I want you to look at your command window. And you notice these are our coefficients. We're getting there. We're close. X. Let's assign fit values. Why do you got to be loud right now, Heater? I am doing a lot, but you can copy and paste some of this stuff from old code. I just like typing. Yep. Any figure number you want. There's a lot of code in this. Oh, 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 oh. Did I miss something? I don't think so. I haven't ran it yet, but I know hopefully it should work. It actually, on Xlabel,
Yeah.
it'll actually make this Greek letter row
That's
right here. Does that work now?
For some reason, it doesn't like the two things that I like.
Yeah, but does it work? Doesn't work? Oh, I forgot the comma after 1. There we go. Let me get mine running. See if I got mine to work. Editor, run. Downloads, save. Hey, look at that.